Bugs, welcome to example 9. We made it. So let's go ahead, solve and write this, or solve this quadratic inequality. I'm noticing a couple things. I'm going to start with it algebraically. I'm going to see what I can do algebra-wise, and then I'm going to check it on my graph. So I am going to eventually use my graphing calculator, but if I want to do this algebra, or without my calculator initially, I'm going to set my quadratic expression to 0, and I'm going to factor out the -2. So that would leave me with x squared minus 4x plus 5. And when I factor out that negative, a lot of times I'll just check, like -2 times x squared is -2x squared. -2 times -4x is positive 8x. -2 times positive 5 is -10. I just do a quick check to make sure I factored correctly. And let me try and factor again. All right, let's see what we got. I've got x and x, and then 5 getting to 4. So I could do a 5 and a 1 with a -5 and a +1. So outer would be -5x, inner would be plus x, but take a look at the last. I'm in some trouble because +1 times -5 is not +5. This doesn't factor, which is fine. So I'm going to use a quadratic equation, or a quadratic formula, excuse me. So in this case, A is going to be -2, B is going to be 8, C is going to be -10, and then we're just going to see where I can go. And side note, I could also use all of these coefficients. Like I could use 1, -4, and 5. That would also work. I'll use the larger ones just because I'll go off of the original. But if you do factor out the -2, right? Because in theory, like if I, here, let me put my pencil over this line just so we can see it. If I divided both sides by -2, I would get x squared minus 4x plus 5 on the left, and 0 divided by -2 would still be 0. So I could make this simpler on myself and do 1, -4, and 5, but just for fun, I'll go with the original. I'll go with -2, 8, and 10. So let's see what we got. We got x is going to be -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so let's start crunching these numbers. So I'm going to have -8 plus or minus, okay, let me move that fraction bar. We got a -4. Let's see what's under this radical. So I'm going to have a negative times a negative times a negative. I'm ultimately going to have something I can subtract here. So this is going to be 80 if I'm looking at it, because 4 times 2 is 8. 8 times 10 is 80. Right, so I have 64 minus 80. So that's going to be a -16 that I'm looking at under here, right? 64 minus 80. And if I wasn't sure, you can always check on your calculator, right? Oops, let me get rid of this. So I could sit here and do, okay, let me clear this out. 8 squared minus 4 times -2 times -10. Sure enough, that is -16, okay? And because that negative, or this negative I should say, is under the radical, I'm going to have an I come out. So this is going to simplify to -8 plus or minus I root 16 over -4. And we know the square root of 16 is 4. So I'm getting closer. We got -8 plus or minus 4i over -4. And I need to divide into both of these, right? So -8 over -4 is going to be 2. 4i over 4 is going to be I, right? And then this plus or minus sticks around. The reason being, if I broke this up, right, I ultimately have -8 plus 4i over -4, and then I have -8 minus 4i over -4, and you can see this ratio here, -4i over -4 is positive I, right? Positive 4i over positive 4i over -4 is negative I. So the plus or minus survives. And really, the headline here is that there are no real zeros. All right, this particular parabola, if I were to graph it, never crosses the x-axis. And let's just check it out, right? I mean, it's fine that it doesn't. It's a matter of just recognizing that it doesn't. So if I plug in, or if I graph -2x squared plus 8x minus 10, and I hit zoom 6, I'm expecting to see something that never crosses the x-axis, and I don't see it, right? Or I do see it, really. I don't see anything crossing the x-axis is what I meant to say. But you can see this is always below, right? It never crossed, which is fine. Okay, so with that, let's go ahead and draw our sign pattern, right? and then see if we can't solve this at the end. Actually write our answer up in interval notation. So I'm gonna have x on the bottom, right? All my x values go below that line, that smushed xy axis. And then my quadratic expression of negative 2x squared plus 8x minus 10 goes above. So I want the signs for these. I don't have any x values, to any specific x values, so I just have to do one test point. So I'll just pick 1. I like plugging in zeros and ones. If I did 1 squared is 1, negative 2 times 1, negative 2. Negative 2 plus 8 times 1, negative 2 plus 8. Negative 2 plus 8 is going to give me 6, right? 6 minus 10 is going to be negative 4, so ultimately it's negative. That means the entire sign pattern is negative, right? Because if it was 0, I would have found it when I set the equation to 0. It doesn't ever cross the x-axis, so I'm never going to have a 0 here. And I'm never going to have anything that even potentially changes sign. And this negative is consistent with what I'm seeing here. This graph was always below the x-axis. All right. And so sometimes we do have parabolas that are always below. In example 9, you saw one that was always above. All right. Now, I want something that is, if I look at this, less than 0. So that means collect negatives. This entire thing was negative. So from negative infinity to positive infinity, my graph was below the x-axis. So that's my end game answer. I don't care what value of x you give me. If you give me any value of x and I plug it into this quadratic expression, it's going to be negative. It's going to be less than 0. All right? Thanks so much, everyone. Bye.